In this section, we're going to be investigating a very powerful rule, which is called the chain rule. And the reason why this is interesting is because it allows us to take the derivative of composite functions or composition functions. Now, composition functions are basically what happens when you plug one function into another. So they have an outer and an inner function. If we can replace the inner function with another variable, we typically use the letter u to help us find the derivative of the whole function. So we're going to take whatever g of x is here on the inside and replace it with a u. So this is what the chain rule says. It says if y equals f of u is a differentiable function of u and u equals g of x is a differentiable function of x, then y equals f of g of x is a differentiable function of x, and the derivative with respect to x of y is equal to the derivative of y with respect to u times the derivative of u with respect to x. So that chaining action, you kind of want to think of it as you have to take the derivative of the outside and then multiply it by the derivative of the inside. So you might see it written like this, f prime of g of x times g prime of x. But you can also remember it in kind of a shorthand way. If u equals g of x and y equals f of u, then y prime is going to be f prime of u times u prime. Now, one thing I want to point out is notice that this u inside of this function we have not taken the derivative of. So we're not going to take the derivative of the inside here, but we are going to multiply by the derivative of the inside out here. So we're going to look at a couple of examples where you would use the chain rule. Now, of course, on this one, if you want to, you can use the binomial expansion, or you can multiply out and turn this into a polynomial and take the derivative of it, which is fine when you have a smaller power of your function. But if that power had been like a 99 instead of a 5, you probably wouldn't want to do that. So this allows us to kind of have a shortcut with that algebra here. So I could write y as u to the fifth as long as I come over to this side and say I'm going to let u be equal to 3x plus 2. So this is our g of x here, okay? And f of u, or y, is equal to u to the fifth. Okay, so we're going to call this f of x, or sorry, f of u. So y prime here is going to be f prime of u times u prime. So I do need to know what each of those are. F prime of u, so f of u is u to the fifth. F prime of u is going to be 5u to the fourth, and u prime would be 3. So this is just 5u to the fourth times 3, or 15u to the fourth. And we just come back and plug in our u, which is 3x plus 2. So this is my final answer here. Now in this case, we're trying to find the derivative with respect to x of sine of 3x. And remember, this is implied that the 3x is in parentheses. So the outer function here, the f of u, is going to be sine of u. And we're going to let u be equal to 3x. So this is the derivative with respect to x of sine of u. Now when you're writing it in this format, it's kind of easy to see what's going down here, because you got the derivative with respect to x of something in terms of sine of u. And whenever that's the case, whenever those variables don't match up, that's a big clue that you're going to need to use the chain rule. So this is going to be the derivative of sine of u, which is cosine of u. So f prime of u would be cosine of u, times the derivative of u, or u prime, and u prime is 3. So this is cosine of 3x times 3, or 3 cosine of 3x, and that is my answer. Now in this example, the outermost thing that's happening here is that we're taking the square root of something. So we're going to let f of u be equal to the square root of u, and we're going to let u be equal to x to the fourth plus 2. So u prime here would be 4x cubed, and we want to take the derivative of that. So f prime of x is going to be the derivative with respect to x of the square root of u. Let's write that as u to the 1/2. And again, the letters don't match here, so this is going to be 1/2 u to the 1/2 minus 1. but then we have to remember to multiply all of that by u prime. So this is 1/2 u to the negative 1/2 times u prime, or u prime divided by 2 square root of u. And when we go to plug everything back in, we get 4x cubed divided by 2 times the square root of x to the 4th plus 2. And then we can simplify here to have 2x cubed divided by the square root of x to the 4th plus 2. Now this is something that can take a little bit of practice to learn, so you definitely want to try a bunch of problems before you go in to take the test on this. Learning how to choose your u is a skill that you really want to develop, because it's something that we're going to be coming back to throughout this course. So definitely pay close attention to it. You kind of want to look at what's the bigger picture versus the small inside picture and choose accordingly. Now, one thing that the chain rule does for us is it allows us to generalize our previous rules. And in fact, whenever you see a derivative formula stated from here on out, you're going to want to think of it in terms of u instead of in terms of x, because that makes it more useful and more general for more functions. So this is an example of what this might look like. This is the general power rule, and this says if y is equal to some u to the x to the nth power, where u is a differentiable function of x and n is a rational number, then the derivative with respect to y with respect to x is going to be equal to n times u to the x to the n minus 1 times the derivative of u with respect to the x. Or if you just want to think of it as u to the n, that's n times u to the n minus 1 times u prime. So we've seen examples of this before, but we'll work a couple more. In this case, my u would be 4x minus 6x squared. So this is the derivative with respect to x of u to the 1/3 power, which we know is going to be 1/3 times u to the 1/3 minus 1, all times u prime, or 1/3 times u to the negative 2/3 times u prime. Or we could write this as u prime divided by 3u to the 2/3. And u prime here is going to be 4 minus 12x. So when we plug that in, we get 4 minus 12x divided by 3 times 4x minus 6x squared to the 2/3 power. And you don't really have to do anything to simplify that. That's about as far as it'll go. Similarly with this one, I'm going to go ahead and bring the negative 12 out, and that's the derivative with respect to x of 3x plus 2 to the negative 3rd power. So in this case, I could let u be equal to 3x plus 2. So this would be negative 12 times the derivative with respect to x of u to the negative 3, which would be negative 12 times negative 3 times u to the negative 4 times u prime, or 36 u prime over u to the 4th, and u prime in this case would be 3. So that will be 36 times 3 divided by 3x plus 2 to the 4th, or 108 divided by 3x plus 2 to the 4th power.